Okay, this is a review for the Unit 9 practice test. So it's not going over all the questions, but the ones that I think are the most difficult. So here's number one. Number one, the chart shows the prices of houses on Oak Street that recently sold along with their original asking price. So what we want to do is we want to go ahead and put the asking price in L1, and we're going to put the sold price in L2. Once you do that, go ahead and go to second y equals and take a look at your scatter plot. You'll notice that your scatter plot looks like a line, a linear regression. However, I had a student try it with a quadratic regression, and we were definitely able to find the answer based on that. So once you do that and you go to y equals, actually you go to stat over to calc and go to your regression, linear regression, number 4. Go ahead and put it in y equals ax plus b. And then once you get your actual line, you would go ahead and plug in 450,000 for x, and that should help you get that answer. This particular problem, it says a person measured the depth of water in a bathtub at 2-minute intervals after the tap was turned on. Use the line of best fit to find the amount of water in centimeters present. Here's the keyword right here, initially. So what you would do is go ahead and put this in L1 and go ahead and put this in L2. Go ahead and look at your scatter plot to see what the data is doing. Get you a regression line, and once you get your regression line, it is linear. You're going to put it in y equals ax plus b. And basically it says find the amount of water present initially. Well, if you look up here, the time starts at 2 minutes. So how much would initially be? Initially would be when x is equal to 0. Okay? So when you get that, go ahead and plug in 0 for x, which you're going to get your y-intercept. And this is to round it to the nearest integer. This would be your, what's it called, TEI question, where you would just type in your answer, round to the nearest integer. This particular question, which graph shows a proportional relationship between x and y. A few things that you can do here. You can definitely plot some points. I'm going to plot points for C. So let me check out C. And so when I plot points, I see 2 and 4. So I'm going to put that on my list, x and y. And I'm going to let x equal 2 and y equals 4. Let me get another point. 6 and 6. Okay. I don't see a relationship. 2 times 4 is 8. 6 times 6 is 36. 4 over 2 is 2, and 6 over 6 is 1. So I definitely don't see any proportional relationship there. Let me take a look at this one here. I found a point here, which is 2, 6. So when x is 2, y is 6. Pin not working right now. Okay, and then another one would be 3 and 9. Okay, I can see a relationship here. 2 times 3 is 6, 3 times 3 is 9. So this one here is your graph that shows a proportional relationship between the two. Also, folks, if you would notice that if it's going to be direct variation, it has to go through the origin. This one doesn't go through the origin. This one definitely isn't going through the origin. And as you can see, that one doesn't go through the origin either. Okay, for this particular problem, we're comparing tires for you to keep rolling tires. The mean, as we can see in the problem, is 40,000 miles. The tires for you have a standard deviation of 1,000, and keep rolling tires has a standard deviation of 1,500. When I look, we're comparing between 37,000 and 43,000. Just to get kind of like a visual on it, this is 37,000, let's say 43,000, and basically the area between here will represent the probability of that taking place. So what we're going to do, we remember the syntax for putting it in the calculator is going to be our start, comma, and then we'll put in our mean, and then we put in the standard deviation. Okay, so let's go ahead and start with tires for you. So tires for you, we're going to start, they both started 37,000. So we're going to do second distribution, normal CDF, and we're going to put in the calculator 37,000, comma, 43,000, comma, the mean, which is 40,000, comma, the standard deviation for tires for you, which is 1,000. Let's see what we get when we put that in the calculator. Okay, so here's what we get for tires for you. This would end up being 99.73%. Okay, here's what I get when I put in keep rolling tires. I get 95.44%. So take that information and you should be able to find the correct answer to problem number 18. Okay, so for this particular problem, in a normal distribution with a probability that a data value will fall below the data value associated with a z-score of 3.37. So let's get a visual on this. All right, so here is my normal curve. Here is a z-score of 3.37. So if I want the probability of the data value falling below that, that's like shading below. So with this in mind, I could eliminate D because that's definitely more than 1%, and I could eliminate B. Okay, so now let's think about this. Here we don't have a mean or a standard deviation, so we're going to make it normal. And so this is going to be 0, and it's going to go over in increments of 1, 2, 3, and so forth. So basically, if I want to find out this area, I would do a second distribution on the calculator, and we always do what? Start, end, and then we do the mean, and then we do the standard deviation. So we're starting from way over here. Okay, so we're starting from the far left, so that's going to be -1, your double E's on the calculator, which is like your scientific notation to the 99th power. We're going to take it there to 3.37, since that's where we're trying to get from beginning to end. The mean, we're going to use our normal mean, which is right here, which is 0. And then we're going to use the standard deviation, which here, the standard deviation, when you normalize things, that'll be 1. So we're going to put this syntax in the calculator. And once we put it in the calculator, we should get the correct answer. Good luck. This particular one, I put it on the review. It can be a little bit tricky. So I definitely want to show you this one, even though, honestly, I will not have one like this on your test. So basically, it says on a day, a city hospital recorded 3 births. So they had 3 births. Let's go here. One for birth, a birth, a birth. The random variable X represents the number of girls that could be born in the hospital on that day. So in my first one here, P of X means only 1 girl born on that day. So here we go. All right, so let's look at this. If the first birth was a girl, and then the next one was a boy and a boy, that would be 1 girl. So what's the probability of a girl? 1 out of 2. So each event, the probability is going to be how much? 1 out of 2, because it's either going to be a boy or a girl. So if we multiply that together, 1/2 times 1/2 times 1/2, what do we get? Exactly, we get 1/8. However, the next time through, if the first born is a boy that day, and then the second time it's a girl, and then the last birth is a boy, that will be the probability of having 1 girl as well. So then that is 1/2, 1/2, 1/2, which is 1/8. So if I have 1/8 plus 1/8 plus 1/8, that would give me the probability of 3/8 having 1 girl. Take a look at this. This X equals 0 stands for the probability of not having a girl. Well, with each birth, you have a 50% chance of having a girl, so this one just totally doesn't make sense. So we will cancel that out. This one here says the probability of having two girls. So if we actually did two girls, we would have to have, put our little lines right here. You know, the first one a girl, the second one a girl, then the next one a boy. And then we can have a boy, and then the last two could be girls. Or we can have the first one a girl, the second one a boy, and the last one a girl. So as we can see, it definitely would not come out to two girls being 50% that it'll be two girls. So that one doesn't make sense either. Let's see the probability of x equal 3, all three being a girl. So the probability of all three being a girl, there's only one way to arrange all three being a girl. Is the first one is a girl, and the second one is a girl, and the third birth is a girl. And what's the probability of having a girl the first time? It's 1 out of 2, 1 out of 2, and 1 out of 2. We multiply those together and we get 1/8. So that one is looking good. So if it was a TEI question, we would definitely pick the first two. Okay, for this particular problem, it could be a little bit tricky. It talks about Miss Jones creating a seating chart. Here it says she has 10 possible students to place in the first row. Now, the thing about it is, even though they want to know how many seats are in the front row, if she was to place a student here, she could only place, if she placed 10 students here, then she would only place 9 here. But when I look at my choices, I have 6, 10, 5, and 4. So here, if it was 4 choices, it would be 10, 9, 8, and 7. And I'll multiply those together. If it was 5 choices, it would be 10, 9, 8, 7, and 6 choices. Okay, and so forth and so on. Well, one of these would give us 30,240 different ways for her to make this seating chart. So good luck finding out which number it is.